Hey guys, welcome back to Genius Learning. In this video I want to show some limits from calculus that I had a little bit of trouble with, so I'm just going to write them simplified out and write some steps that confused me when I took calculus. So we have this limit where x goes to infinity, and it's going to eat inside of the 1. The function is 1 plus 1 over 3x, all raised to the x. So the first thing we want to do when we see a limit is plug in the limit. So if we plug in infinity here, we're going to get nothing here, 1 plus 1 over infinity. 1 over infinity is 0, so we stay with the 1, and 1 raised to the infinity. So this is going to be 1 raised to the infinity, okay? And if you don't recognize that, then I'm going to write here the 7 indeterminate forms that you need to look out for whenever you first plug in, or whenever you do L'Hopital's or L'Hopital's rule, however you like to pronounce that name. Let's see, and we have the last two, infinity to the 0 and 0 times infinity. Okay, so these are the 7 indeterminate forms. If you see these, then that means you have to do manipulation to the limit. Okay, so if you have these terms, you can do L'Hopital's rule. So let's rearrange this right here. All we're gonna do is some algebra. Okay, I'm just gonna rearrange it. I'm gonna write the limit, okay, as x goes to infinity of e raised to the x ln of 1 plus 1 over 3x raised to the x. Okay, this is the same thing as this, right? Let's look at properties of ln first. So if you have x ln of 1 over x, for example, this can be written like this. You put the x, or the constant in front of the ln, to the power inside, and so you have 1 over x raised to the x. Okay, so these two things are equal. These are the same thing, and so that's a property of ln, and because of that, here, all right, we're not supposed to write this here. Okay, so e x ln, all right, so if the properties of ln are applied here, we put the x back to the exponent, and the e and the ln will cancel out, leaving us with this only. Okay, so all we did was rearrange it. So this here is the same thing as this, and it's raised to nothing. This was a mistake here. So now what we're gonna do is another manipulation step. We got the limit as x approaches infinity, and I'm gonna bring out the e all the way over here so it doesn't bother us for now. And we got these two terms left on the inside, x ln of 1 plus 1 over 3x. All right, so we still can't do anything, because if we plug in our limit as x approaches infinity, we got infinity and 1 over infinity is 0, so ln of 1 is 0, and you got infinity, and so that's an indeterminate form, and we can't do anything with this. Let's change it up and make it look different. So we're not going to evaluate anything, we're just going to keep rearranging it. Okay, so limit as x goes to infinity, the e is out here, we got ln of 1 plus 1 over 3x over 1 over x. And so I turn this x into a 1 over x, because if I flip it back up, right, this is for a small algebra review. So if you have a over b divided by c over d, then you can flip the bottom fraction up, and you'll have d on the top and you'll have c on the bottom. Okay, so you took this fraction down here and you flipped it to the top, and now they're going to multiply across. So you don't need this bottom term anymore, and you multiply across. So that's what this is doing. So if I have ln of all this stuff over 1, right, that's a fraction on the top, ln of all that stuff in there over 1, and then the big line, which is this one right here, over 1 over x, right? Then using this property, I can flip this fraction to the top. I'm going to flip it on this side to the top over 1. So the x was on the bottom, now it's on the top of this fraction, and this was on the top, now it's on the bottom. So we don't need this fraction, we don't need this line here. And so you see how the ones don't matter. And so you see how now we have x ln just like we had right here. Okay, so just some manipulation there. All right, so now when we plug in, so here along the way, let's write what we were getting. Here we got, when we plugged in the limit of infinity into here, we got infinity, and we plugged it into here, we got 1 over infinity, which is 0, but we still had ln of 1, which was 0. And then now we're gonna plug it back in and see what we get. Limit as x goes to infinity, in here we got ln of 1, which is 0, and 1 over infinity is 0. So now with this indeterminate form, let's use L'Hopital's rule. Okay, so for L'Hopital's rule or L'Hopital's rule, we take the derivative of the top and the derivative of the bottom. All right, so don't mistake that with the quotient rule or maybe a product rule. Okay, it's just the derivative of the top by itself, and then you do the derivative of the bottom by itself. Okay, so I'm gonna do the derivative of this top part, and so a review for derivatives of ln, we got ln of u, right? And if we take the derivative of this, that's gonna equal the derivative of the inside over the inside. So this right here is the derivative of ln u. And so we have ln of all this stuff. Let's take the derivative of everything in here, okay? First, let's express this a little bit different. We got 1 plus 1 over 3 x to the negative 1. Okay, so I'm just rewriting it. Now let's do the derivative of this inside, which is the derivative of ln. And that's gonna be, drop down that, this is gonna be a constant. We're gonna drop down the negative 1, so negative 1 over 3 x to the negative 2. And take away 1 from the top. So this is the derivative, and then we have to divide that by the original thing inside. So this is u and that's u. So 1 plus 1 over 3x. Okay, so this is on the top, and this is on the top also. All right, now let's do the derivative of the bottom here. And so I'm gonna write this different before I take the derivative of it. 1 over x is the same thing as x to the negative 1. So now let's take the derivative of this. The negative 1 comes down. We have an x to the negative 2. We take away 1 from the top. And this is also like writing 1 over x squared. So we're gonna use this notation right here. Okay, so this is the derivative of the bottom part. So let's write that right here. 1 over x squared, and that's negative. All right, perfect. So this entire thing here is a result of L'Hopital's rule. We took the derivative of the top part, which gave us these two terms as fractions, and we took the derivative of the bottom, which gave us all this in red. So let's put that back into our function here in the limit, and let's see what we got. So we're gonna write e to the limit as x approaches infinity, and negative 1 over 3, negative 1 over 3. X to the negative 2 can go on the bottom as an x over 2. So just like here, x to the negative 2 becomes 1 over x to the second. So we're going to do 1 over 3 x to the second. All right. And then we have this. So we're going to keep that like that. And then we have a bigger fraction here that is 1 over x squared. All right. So let's deal with this in parts first. So let's deal with the top part. Okay, I'm gonna deal with these two fractions, or I'm gonna rearrange this in order for us to have two fractions. So I'm gonna write the top the same, and then this bottom here, least common denominator, I'm gonna have 3x plus 1 over 3x. Okay, and now I have a fraction over a fraction, so I'm gonna flip it up, and I'm gonna have this here flipped upward, so this is gonna be 3x, and this is gonna be 3x plus 1. Now we don't need this term because we just flipped it up here, so the 3's cancel, one of the x's here cancel, and we're left with negative 1 over x 3x plus 1. Okay, this is what we're left with from all of this in pink. So let's rewrite everything. So we got e to the limit as x approaches infinity. For the top part, I have negative 1 over x 3x plus 1. That's this part here. And then the big line here, and we have the bottom part as negative 1 over x squared. All right, so we can already take away the negative sign, so negative divided by negative. And we have a fraction over a fraction, so I'm gonna flip this to the top. Here it's on the bottom, now x squared is on the top, over 1. Sorry, we eliminated the negative, so it's just x squared over 1. And we don't need this anymore because we just flipped it up. And so now let's get rid of one of these and one of the x's on the bottom. So we're left with an x on top and 3x plus 1 in the parentheses. Okay, so let's continue to write it here, and let's see what we got. So e raised to the limit as x approaches infinity of the remaining term that we're left with, x over 3x plus 1. Okay, so now we got one more move to make before we're home free here. So we're gonna take out a 3x from these two terms. Okay, so it may look weird at first, but try to follow how I do it here. 3x plus 1 in parentheses, right? Let's say I pull out a 3x from this term and a 3x from this term. It doesn't have a 3x. So what do? We take it out from here, 3x, right? And in place, we just write a 1, because when we distribute it back, it turns into 3x, which is what we have. Plus, right, if we took out a 3x from something that didn't have a 3x, then we're gonna need a 3x on the bottom with nothing on top, the 1 on top. And we need it on the bottom because when this 3x is distributed into the second term, it cancels out and you're left with 1, which is this. Okay, so first term, you take it out, equal to 1. The second term that doesn't have it, when you take something out, you just divide by it. So that way, when you FOIL it back in, it can cancel out, making a 1 again, or making the number that you need. Okay, so we write this expression here on the bottom. So you see how 3x plus 1 changed to be everything here in the box. So in the same way that this bottom part, this 3x plus 1, is going to change to be 3x 1 plus 1 over 3x, and that's only on the bottom. That's all still over x. Okay, so we don't need this anymore because we just re-expressed it as this now. We can cancel an x, and now it looks like we're home free and ready to evaluate this limit. So x approaches infinity, e, and we have 1 over 3, 1 plus 1 over 3x. All right, now if I evaluate this integral, okay, I'm gonna put this right here. So if I evaluate and put x, the limit as x goes to infinity into here, 1 over infinity is 0, so we're left with 1 on the bottom times 3, and so we're left with a 1/3. Okay, so we have the limit as x approaches infinity. We still have the e, remember, and we got 1 over 3, because this 1 over infinity turns into a 0. We're left with the 1, and now we don't have to write the limit since we evaluated it. All right, and we're left with e to the 1 over 3 as our final answer. All right, so a lot of tricky algebra there and some gross manipulation, but there you have it. You can use these tools. There's a lot of limits that have this type of algebra in it. All right.